This beautiful underwater world, known as the kelp forest, is home to many forms of kelp and seaweeds, along with many fish and other organisms such as harbor seals and sea lions. Specifically, these forests are located in the islands of Isla San Benito, located in the Pacific Ocean off the coast of Baja California. Without the turbulence or fast movement of the ecosystem, this kelp forest would be unable to thrive. Turbulence, which describes fluctuation of motion within the ocean, as you see in the kelp forest, can be driven by many factors, including breaking of surface waters by steepness of a wave, propagation of internal waves through density gradients, wind forcing water to move down water layers, and large currents creating large water movements that break into smaller motions all colliding with one another. Plants such as kelps and seaweeds contain a boundary layer around them that causes speed of flow of water around their blades to equate to zero, allowing for less nutrients to be obtained due to lower diffusion rates. Just like the kelps and seaweeds seen here, the boundary layers can become thinner due to the speed of water moving past them. By attaching to substrates where turbulence in water movement is high, their boundary layer becomes thinner, allowing more nutrients to be consumed by the plant through diffusion. Adaptations such as being more flexible in high water flow allow plants to remove predators such as herbivorous organisms that feed on the blades of kelps and seaweeds, saving them from being eaten. When they adapt to be less flexible, they may be able to outcompete with their neighboring plants to capture more sunlight, which is essential for photosynthesis. Marine algae and other plants seen here may also alter the way they grow in order to limit the dangers of drag they might experience in high turbulent areas. If drag is too intense, they could be ripped from their substrate, resulting in the death of the plant. The motion of turbulence is highly important to the productivity of the ecosystem, allowing nutrients to be dragged closer to the plants and waste to be dragged away from them. The slower the flow against the blades of the plant, the lower the photosynthetic rate, which equates to lower primary productivity overall. These marine plants are able to adapt to their changing turbulent conditions in order to maximize productivity and survival.